Hey there, Kennedy at CCX. Today we'll be taking a look at the avionics IDS on the ARINC 429 bus using the AP250.
This video demonstration will show how one could use the SystemX Avionics Intrusion Detection System to detect anomalous ARINC 429 data. We will first go over the equipment under test, then we'll take a look at the ARINC 429 injector setup. Lastly, we'll demonstrate the avionics IDS in action.
Okay, now let's take a look at our setup. Here we've got a flight path being written to our GPS synthesizer. Our GPS synthesizer is outputting a signal to our GPS receiver. The GPS receiver is then encoding that positional data and writing to our ARINC 429 data line. The data file, the AP550, is capturing that positional data in the ARINC 429 format, then writing it to an Ethernet packets, which are being written over an encrypted link to our AP250. The AP250 is then receiving that data. It is analyzing it using our avionics IDS. The avionics IDS is going to use a number of rule sets to inform itself on whether or not it's erroneous data or not. In addition, the AP250 in this case is writing to our moving map. This is the moving map that a pilot would see. On the right here, we've got our oscilloscope. The oscilloscope is capturing the ARINC 429 words being written from the GPS receiver to the data file. Here we've got the ARINC 429 injector. This will be used to inject erroneous data onto our ARINC 429 line. Okay, now we're going to take a look at the ARINC 429 injector setup. On the left we've got the USB oscilloscope. Right now, it's probing the ARINC 429 line between the GPS receiver and our data file. You can see the bulk of the messaging here. This is all correct data. This is going to be the data showing the simulated flight path. On the right, we've got our injector setup. This is going to be injecting the erroneous data onto our line, which we can expect to pick up around here. So right now we're running the injector. It's inputting the ARINC 429 words on the line. You can see that we're picking it up using the oscilloscope. It's a little bit past the word so that we don't actually change the data coming from the GPS receiver.
Here's another look at the monitoring equipment. On the left, we have the flight simulation software, which we'll use as reference data. On the right, we have the oscilloscope capturing the ARINC 429 data. On the phone, we have the moving map. This would be similar to what a pilot would see in a glass cockpit. For ease of viewing, I have the video feed from each display in boxes on the screen. We are now looking at 3 video feeds we just touched on, with the addition of our SystemX alerts log. The alerts log can be found in the top right corner of your AP250's landing page. Our alerts log provides real-time alerting based on your avionics IDS rule sets. In this instance, our rule set is configured to monitor the ARINC 429 data bus for any erroneous or anomalous positional data. When a rule is triggered, an alert is generated. Depending on the configuration, SystemX can notify users on board the aircraft or the remote SOC or SIEM for further investigation. Now let's proceed with the simulated attack. In the top left, you can see the reference path of the aircraft. This would be the real position of the aircraft. In the top right, you can see the path of the aircraft as displayed on board by the glass cockpit. This moving map will present the spoof positional data as real data to the pilot. As I inject the ARINC 429 words onto the bus, the oscilloscope will capture the false data. The false data will appear as a burst on the right of the oscilloscope grid. Here we go with the attack. I'm now injecting false ARINC 429 data onto the data bus. As you can see, our SystemX Avionics IDS immediately identifies an abnormality on the ARINC 429 bus and provides an alert stating unrealistic rate of change GPS longitude. Our avionics IDS analyzed, triggered, and alerted before the moving map could even capture the change. If you'd like more details on what triggered the alert, you can select the alert. Details include alert description, the source bus, the source device, the rule that was triggered, and more. For more information, please contact us at info@ccxtechnologies.com or drop us a line at 613-703-6161.